So again, I have uploaded on Avenue the detailed example we have went through in the past two lectures for linked lists using different methods of insertion, deletion, and searching. So hopefully you find this useful as well and can be reusable when you think about Lab 5. Just to lay down what we have until the end of the course. So we have basically 2 weeks remaining. I mean, I believe except maybe the next Friday where we don't have a lecture because the last day is on I believe Thursday, December 8th, if I recall correctly. Yep. So we have, well, today's lecture, Friday, and then other 2 lectures, next Tuesday and Wednesday. Today we are covering templates, which is an important topic in C++. So simply C++ adds different capabilities compared to C. This includes object-oriented programming, but C has much more than OOB. So it has this concept of templates, and there is another important topic to cover in C++. That is the STL, the standard library basis and template library from C that includes some of the data structures that you can use. These 2 topics are important because if you go outside and say, well, I have learned in C++, you cannot really state this without knowing these 2 topics. At least having a starting point. We'll not be able to cover them in a bit of a detail because this might in fact need a course in its own, but at least I will give you hints on using them. My, I would say, maybe optimistic plan is to finish templates today, introduction to STL tomorrow, and hence we are left with 2 lectures that I'm thinking either to cover recursion, as I said yesterday, or give you recursion video recording slides as an optional material, and maybe do a review. So I will think during the weekend, and I will let you know. But for this week, at least we'll be finishing C++ part by Friday. Okay, so it's already 33. Let me see if there are questions on the chat. Are we moving to in-person? Well, I'm not very sure, in fact. So I tried to go to campus. It's a bit unpredictable. That's the problem. I wanted to move to in-person as of this week, in fact. But last week I went to campus on Friday and I was delayed by around 15 minutes. So it's a bit not deterministic. But let's see what we have. I will re-counsel again with Professor Scott for the other section and with the department. So just to know, the department and university recommendation is just we stick to the contingency plan by being online until the end of the semester, right? That's really the recommendation. But we will see based on the situation what to do. What we have done this week is we transformed the labs and office hours at least in person because this would require more interaction. So hopefully you find this useful. Would you need recursion for 2SI? Recursion is an important topic that you would need, in fact, in any professional programming. I will share with you a personal experience, given that you asked this question. So after, well, I guess in 2017 or 16, I believe, I was doing some interviews for a hardware company, and out of the 9 interviews, I had at least 6, so 2/3 of them were software, despite being a hardware company. And I'll tell you, with those 6 interviews, 5 of them, they're only solvable within the given time using recursion, right? Which was kind of surprised me because you only receive kind of 20 minutes to solve the problem. And if you already don't use recursion, you will take much more than this, even if you know the solution. Because like not having recursion would require you to think carefully about the algorithm. But recursion facilitates some kind of problems that would require keep calling the function again and again. I hope we'll be able to cover them next week, but if not, at least I will give you my video, my slides, and hopefully this should be enough. Okay, so let's start by discussing, otherwise not be able to finish templates today. So what are templates? So let's revisit one slide that we had earlier, which is the very first slide that I believe Shuruk has covered with you, which is when we were discussing C++ versus C, etc. And this is function overloading. We have also covered function overloading as part of the polymorphism last week on Wednesday. So what is function overloading again? You have a function with exactly the same name, but the signature is different, right? For example, here I want to print, let me enable the pen. Hopefully this works easy. So I want to have a function that prints some sort of a variable. And then assume that this variable is an int, for example, then it takes int as an input. So if I want to have a different flavor of the same function, but it takes some sort of a string as an input, which is a character pointer, then, well, I will implement it differently, and this is called function overloading because the function has the same name, but different type of input parameter, right? We already know this, right? So simply same function doing same functionality, but applied to different types, basically, right? So the observation here is that the two implementations of the print on new line function are almost identical, right? You have a cout, you have some sort of a variable that you want to print, and then you print x, right? So aside from basically this string that you want to print, which is either it's integer or string, you are in fact doing exactly the same thing, right? So now what if in fact you are building some sort of a program or library that you want to have a print on new line for every single type, int, character, double, float, etc., etc. Does it mean that you need to re-implement the function using overloading? Well, and then have exactly the same, more or less the same line. This is in fact obviously a wasteful effort and redundant effort, right? And this was the motivation for C++ to come up with this concept of template. So what if there is a way that we can have a generic code that is type independent, okay? And then the compiler itself, with some magic, it's able to translate your generic code into the specific type based on how you call the function, right? And that's exactly what the templates do, right? Templates is an extension of polymorphism. It's a compile type or compile time polymorphism where you can have generic code that later on is substituted with the exact type. And this is the notion of templates. So simply a function or a class accepts type as a parameter. Type can be anything. It's a generic type. Later on, when you call the function, you call it with the specific type you want. So when you define or declare the function, it's type agnostic. So it can operate on any type. And then when you invoke the function for a call or for a class, when you instantiate the class creating an object, you now specify the type that you want to operate on. So let's revisit the example that we have for the print on new line and see how this happens. But just to understand it a bit more, when this kind of substitution happens, when you call the function at compile time, the compiler will look into the function call, know that, for example, now you want your type to be int, and then it will generate the specialized code for you, right? So the idea here is that you put some sort of a template code. There is not runnable, in fact. It's not a correct runnable code. But then the correct code is only generated at compile time based on your function call, right? This seems a lot as a concept. So let's really see it in practice, right? And then see if you have questions. If I go back to my previous example of having two functions of print on new line, now I have done something different. I kind of define the function only once. But then ignore this line for now. I will explain it to you in a second. But if you look into that implementation, just instead of having an int or a character pointer or a string or a double or anything, I just had a generic template name called t, right? I can call it anything. And then I'm operating on t simply. And then here, because I want to print the type of the variable, then I'm using what I call type id.name, but that's a special function that exists that gives you the type of a certain variable, and then you print x. But the key idea here is that now the function signature is independent of the type, so it's type agnostic. It just takes t as a generic template. What is t? Here comes the need for the first line here, the one that you put above the function or the class, which is the template definition. So here you say that this is a template function by using the reserved word template, and then between these two kind of special brackets, you write type name and t. So you are defining t as your own template type that later on you substitute with the correct type. Good. Then now when you go to the function call, you are in fact calling the function based on the variable. So here we don't really specify what is the variable that we call the function in, because it's obvious from the variable. It's just a single one. Later on, I will show you really how you can specify t to be of a certain type. But here that's implicitly done by saying x here is an int. So the compiler will go based on this line and create an int version of the function. So it would replace t with int simply, because t again is a generic type that later on replaced with the correct type. And then afterwards, once the compiler hits this character y, so again it will create another instance of the function where it replaces t with a character. Good. So that's the whole idea of a template. So let me stop for a second and see if you have questions. So it's a type ID, a function that is return a type. Yes, correct. But that's in fact has nothing to do at all with templates. It's just the way we use the function, because we wanted to print this special integer and string variable here, right? Like this kind of string, right? But the templates operates independent of this. But yes, type ID is a function that returns the type of the variable x, and basically here dot name means, well, type ID is a class, and then basically name of the class is the type of the variable x. Yes, it gives you integer or string, right? Or a character based on whatever type you are passing. But ignore type ID for now, because that's not really the main focus. Let's focus on the template, which is, these are the two things, this generic type t and this line where I'm really defining t as a type name. Is there any question? I mean, logically, this kind of makes sense, right? It facilitates your way of writing code. Instead of having different versions of the same function, if you're only changing types, you make your code generic that is type agnostic. And that's one of the powerful things about C++. Questions? Okay. So let's have another example where I want to show you, okay, so Maya, what do you have to create your template in a separate header file? I will come into how to create the templates, header files, and source files for now, Maya. Just bear with me for a second. We'll have another example, and then I will tell you, because templates has a special thing related to header files. I will come into it in a couple of slides. Let's see another example where in fact you can specialize your function call with the correct type. So assume I want to have another template function called compare that simply just takes two things now, two generic things. I don't have specific types, and then compare them, return certain value based on which one is larger, right? Previously, before we know templates, I would have to write this function compare again for ints, for doubles, for floats, etc., etc. But right now, I can write a template function again using exactly the same line here. By the way, t can be anything, right? I can call it thing, right? Like t just here is a user-defined name, so it's up to you. And then I'm having my signature of compare. Instead of being dependent on a type, I'm making it dependent on t. I'm making here it constant because simply this is comparisons. I don't want to change the variables, but it doesn't really matter. And then I'm just simply taking the two values, compare them. If value 1 less than value 2, return -1. Value 1 is larger than value 2, return 1. If they are equal, you can return 0, right? So this is basically how it operates. Now, the interesting part is that I want to use compare to compare different types, right? So here I'm defining two strings, hello and world, and I'm defining, and I'm also using compare to just simply, first of all, compare two integers. And that's the part that I want you to understand or focus on. This kind of specialization of the function. Here it's int, here it's string, here is double, right? Now I'm telling the compiler what version of compare I wanted to generate. So here I'm operating on integers, so I'm really having after the function name the specialization, the instantiation of the type name t. So now the compiler will bind t to be an int. So it will create a version of your function to be an int, and then a string, and then double. And then the function, well, all of the sudden magically operates on all these different types the same way correctly, right? Does this make sense?
Professor?
Please.
Could you go into a bit more depth about the syntax with the typecasting when you call each version of the compare template?
Yeah, this you mean this one, right?
Yes.
Yeah. So simply we wrote the template function, okay? But the template function is operating on a generic type T. When I call the function, I want now to bind which function type I want, right? So in a sense, you want to replace, substitute T with the exact type. The way to do it in a template function is you open, that's the exact syntax. After the name, you open these two brackets, and then you write the type that you want to operate on. Simply here, I only have T, which is a single type. I want to replace it with an int. So I'm writing this to be an int. If I want it to be string, then I will write string. If I want it to be double, then I will write double, right? So the rule is when you do the function call, or later on when you instantiate an object out of a class, where we'll see like how to do templates on classes, the way to do this is in front of the name, you add these two kind of angle brackets, and then you write the type that you want to operate on, right? If it's an int, double, any valid type would in fact work, right? These are just examples, but you can extend it by having a character, float. It's up to you. Does this help, George?
Yes, thank you.
Thanks. Kurt, since you define the type of the compare function as t, do both arguments have to be of the same type when you call function? Yes. Well, that's a good question, Kurt, because here I'm defining the two values to be of the same type because that's really what makes sense for a comparison. You don't want to compare values of different types. But it's not a limitation of the template. You can, in fact, have a function that operates on different template types. For example, let's say I'm writing my monomial function that we wrote earlier, right? Or monomial class. And then this monomial would have an exponent and the one that we have in the structure, for example. It would have an exponent and it would have like a mantissa, right? Like the basically the actual value in front of the exponent, right? In that case, this can be a float, this can be double, this can be double int. It's up to you, right? Usually for floating point representation, the exponent is int while the mantissa is double, right? In that case, you can write a template function that really takes multiple template types. And when you substitute, you would substitute them now, this syntax, and instead of just writing a single int thing, you also pass it as double, for example. And then again, the binding will be based on the order, right? So here you write another type name, and then let's say T2. And then the int will go for the first one, the double will go for the second one, right? So in general, a function or a class, or when you generate a template generally, the template can operate on multiple template types. It's not necessarily a single one. But here in this example, we're just taking it simple that all the types of all the variables or the input parameters are of the same type. Can your function return a type T? That's also a good question, Cheng. Yes, the function can return, but let's see really how these things will. We'll come into this. Just you guys are asking good questions, but let's have them one by one. Okay. So now going back again to the rule or to the basic. So the compiler doesn't generate any code when it sees the template function. So generally what happens is that when the compiler combines your code, it just really generates the binary for your code, right? As part of the compilation process. But remember that now a template is not a runnable code, right? It's just a placeholder. So the compiler will not generate the corresponding binary, for example, or assembly of your template function because it doesn't know yet what type to generate, right? When it will see the function call, for example, or the class instantiation, then it knows what type you want to bind to. So in that case, the compiler, based on the function call, will go back to the template definition and replace it with the exact type, right? So the compiler does the job of redundancy that you eliminated from yourself. Good? At compile time. Now I come to the point of the problem with templates and header files. So this comes from the discussion we had in this slide. So what really the compiler do in the background is that it looks into your code, and then it doesn't generate any code when it comes to the template definition, but when it go to the instantiation, it goes back to the template definition and replace it with the exact type. The problem here is I told you before that it's a good programming practice to in fact separate your interface from implementation, function signature from function prototype, right? Or definition. So in that case, for our compare, What makes sense if you apply the rule that I kind of taught you before is you will have a separate compare.h file that only has the function signature, and then you have another compare.cc file where you do the actual implementation, right? And then in the main, you will be simply including the compare.h, and then it will be replaced, right? That's what we have been taught so far. The problem is, well, this doesn't in fact work with templates. Can you guess from the previous slide why that's the case? If template functions are generated when called, does that mean we could have a call to the template function before it's defined? Well, in fact, Stefan, that's also a very good question because the compiler doesn't generate the function when it sees the template, but it keeps track of it, that there is a generic placeholder that later on I need to revisit and replace. So if you really did the function call before its definition to go and replace the actual generic placeholder, right? Because this is what the compiler actually do is I know that there is a generic placeholder somewhere that once I have the function call, I go back and replace it with the actual definition. But if the compiler doesn't know where is the exact template, well, it cannot really replace it with the exact code, and that's really a problem, right? And this is in fact related to the question I'm asking here is one reason why separating the implementation between header and CC files does not work for templates is that exact same reason, is that remember the procedure. The compiler will go through your header file. It will know that there is a template here, so I don't generate any code. I go through it. Once I hit into the function call, I need to go back and replace the implementation in the place where I had the actual template. The problem now is that where you had the actual template in the header file does not have the implementation. So the compiler doesn't know where to go to find the actual implementation, right? And that's the problem. The reason is that simply when you instantiate a template, the compiler creates a new class with a given, well, a new class or a new function with a given template argument, and the compiler need to have access to the implementation. The problem is that when this implementation, if it's not in the header file, it's not accessible by the compiler and it cannot really generate the code. The easiest and workable solution for this so far is in fact to include your implementation in the header file, right? Just to do this. This goes against general recommendation for separation of interface and implementation, but this only applies for templates, okay? Yeah, well, that's an excellent question, Dionine. In fact, I like it a lot because the question is saying, does the generic type name, the templates in general process, makes your runtime slower because it needs to go back to the code, etc. It's very important to understand that this kind of replacement or generation of code does not happen during runtime. Remember that what we said is runtime is why the code is executing. This happens at compile time, where the code is being compiled to generate the binary, right? So in software engineering, there's a big distinction between static time, which is compile time, or dynamic time, which is the runtime, right? Runtime is where the code is actually being executed, and this is where your performance matters. But this code replacement only happens statically while you compile, when you hit the build in Eclipse, basically, right? Not when you hit the run. Hopefully that's clear enough, right? So this process we have here, put in mind that simply uh, this happens, let me see, I have a note here that this really happens at compile time, right? This slide here, right? So this is compile time or build time, not runtime. Hopefully this clarifies this concern. Good. So as we said, the solution, in fact, to this problem with template is to just include the implementation in the header file. That's the only way that the compiler will know where the exactly the implementation is. It's accessible, and in that case, it can replace it with the exact code. Good. So far, we did run an example for templates with functions, right? But templates in C++ are also applicable to classes. In fact, templates came out of the need for specialized classes, right? So assume, for example, just have a very hypothetical case where you want to write a class that holds a pair of things. And for this pair of things, you want to have generic functionality that setters and getters set the value of the first thing, the value of the second thing, get the value of the first thing, get the value of the second thing, maybe swap the two values of the things or print them, right? Do generic stuff on these things, whether these are things integers, doubles, floats. My generic code should be independent of this. So in that case, I will apply exactly the same methodology of templates as we had before in front of, and by the way, this can also be a separate line similar to what we had in fact, this is how I prefer it. Let's just discard, and then just in order not to confuse you, I will write it that way, right? It's recommended that you always have the template definition as one. Let me just make this readable. Okay. It's always recommended that you have your template here as a separate line above the function or above the class, and you do exactly the same way, right? With for the class or for the structure for the function, the template is always defined by using the reserved word template, and then you write the reserved word type name in these two brackets, and then the generic name that you give for your thing, right? For your type, for your template. And then now I write my class very normally, but instead of operating on a certain type, I operate on my general template placeholder thing, right? And here comes the question that someone of you already asked it. Can a function really return a template type? As you can see here, all the getters will return the first thing or the second thing. Hence, it will be returning a thing, right? So here I'm writing very simple getters and setters. For the get, I'm just returning the first, returning the second. For the setters, I'm basically taking a value and then place it in the first thing as will come into the implementation. The same thing for the second, and swap the same thing. Good. And here I'm defining general my two pairs basically as a thing, right? Where that's the first and that's the second. Good. Now, one thing to observe is that to get the templates to work correctly, we have included the source code of the bear in the header file, right? You could write it that way and still have the implementation in the CC file, or just copy the implementation and put it here and have a single file, right? But the reason we have done this is just to follow again the norm of recommendation, which is just simply you separate the implementation from the interface. So Daniel, why do you have and copy me? That's the input parameter that you want to copy to the first thing. I guess your question might be why I really pass it by reference, right? You don't want really to modify this, right? That's correct. But maybe it's a guard against. What if you want to pass a pointer instead of like when, for example, what if these things are pointers for you, right? So you never know. So that's the reason why you might just want to keep it generic. But if we're talking about normal types, yes, you don't really need the end.
Yeah,
There is
so
a
I
hand
also
up, please
noticed,
go ahead.
yeah, sorry, I also noticed in your previous implementation, whenever you have a type that's not determined, use the and operator on it. Like, I don't know why you do
For
that.
the same node. That's a good idea. Yeah, for the same node that I was saying, because if you want your template to be generic enough, you might also want it to operate on pointers, right? Because pointer is a valid type, right? So in that case, for example, I want to compare two pointers or do something with pointers, then, well, you just pass things by an address. If it's a pointer, it should operate on, right? And then if you operate on normal types, there is no harm of doing this. For example, here we define it as a constant because we say we don't want to modify, right? But in order not to confuse you, again, that's not much has to do with the template terminology. It's rather being a bit generic, right? But it's not necessary. If you know that you will never, for example, operate on addresses, it's okay to pass them by. It's not mandated. It's not required, right? Just to make sure that's very clear, right? I can still really have here a normal variable that is of type thing X, and it should operate fine.
Wait, so okay,
Okay.
just to confirm,
Yeah.
sorry, one more
Yeah.
thing.
Sure.
Thing is like a class, right? And it takes in a type of a variable and probably takes a pointer to that type, and then it generates a more generic pointer. Or am I
No,
wrong?
no, 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 no. That's
Not
that.
really?
Okay, Daniel. That's an important point. So first of all, thing is not a class, right? Thing is a generic name you come with. So it's like your own user-defined type, but it's generic that later on will be replaced by the correct type, right? So and the way that we define it here is by using this template thing. So a template is different than a class, right? So it's not a class, right? It's just a placeholder in your code that later on the compiler will replace by the exact type, correct? Do you see what I mean?
Yeah, I see. But I still like don't really understand why you want to pass it by reference all the time.
Good. Sure. Well, what I'm saying is that you don't have to.
Oh,
Right?
okay. So
What
it's
I'm
just good
saying is,
practice.
yeah. So what I'm saying is that if you want, for example, what if you want your template function or class to operate on pointers, for example, right?
Yeah.
In that case, you would have ready to pass things by reference. So you need the AND operator, correct?
Yes.
So in that
So
case, you
then,
want your thing to be generic enough to include that case. So it's a good practice, but it's not required. If you know that you are no longer operating on pointers or passing by reference, you should be good. Hopefully that makes sense.
yeah, makes sense. Yeah. Thank you.
Sorry, yeah, Daniel, it's still not okay. Good, yeah, thanks. If we got the time to write a code, we will try it with the and without the and we'll see what happens. Okay, so now going to the implementation, again, nothing very special. Once you already define the template, you just operate as is, right? Here, these are the setters. It gets thing as an input. I'm just setting my first variable to be a thing. And then again, the same thing for the second. Here, the underscore, don't worry too much about it. Here, it's a C++ terminology. If you have private variables, you just write them with an underscore at the end to know that these are your private variables, but it's not, again, required, right? It's just a terminology. And then here for the swap, here comes the interesting part. I need to define a temp. We do the swap similar to what we have done before, right? And then in that case, I'm defining a temp of type think, and then, well, do the swapping for the 3 steps we already know, right? And then I'm done, right? Great. And then, well, forget about this one for now because we didn't really do an operator overloading in C++. That's a topic that we don't cover in 2SH. But the idea here is, again, I'm trying to print my two pairs in a sense. But this is called operator overloading, but I can write it as a normal function. I will change that code and update it as a normal function when I repost it on Avenue as well, in order not to confuse you. When you implement the scan, each object has its own type thing, or does the first object? Yeah, that's a good point here. So because we defined, Kurtz, because we defined only one template type here, that's the only one you know, thing, right? But if I want to generate, again, because this is where pairs are being compared, etc., etc. But as I was giving the example of a monomial, if you want to generalize it with different types, you can still have simply different type defs, right? You write something like type name, and then you write thing2, for example. And then now you can have the first as thing and the second as thing2.
I guess
Or
my
does the
question
first
was,
object define what type thing will take during the runtime? Sorry, go ahead, Bruce. Yeah.
I guess my question was, say you define an object of this class and is using this template thing, and say for thing it first takes on an integer. Can the second object that then take on, say, a character instead? Or is it as soon as you use an object with these in this template or in this class, would that restrict it to integer?
Yeah, I'm not sure if your voice was cutting only for me or that's for everyone, but I kind of tend to believe that I have got your question. For example, assume I only define my class that way, but when I create an object, what if I want the two first and second parameters or member variables to be of different type, int and something else? What I'm saying is that if you do it that way, that's not possible because here you are saying that my class my writings become very late, so it might be, in fact, this cutting was also on my side. Let me see. You guys still hear me, is that correct? I'm still online. Okay, good, thanks. So yeah, because here my tablet kind of, I believe, let me make sure that it's some sort of a delay. But basically the idea is, if I define my template that way, using only one type name, I cannot really assign that anything other than this type name, right? You can, if you want, to have, for example, your first as a generic name, but then you have your second as an int, something you already hard code in your template class, right? But you cannot have thing and thing2 because you never define thing2. So when you call or you instantiate an object, you cannot say an int and a double. It doesn't really work. The only way to get this to work is to define another. Well, here I need to write, so I need to check what is going with the tablet. So just give me a second. Simply, you need to extend what I was just saying earlier. Why it's being delayed? Let me stop sharing and then share again. I see it as a black screen. That's interesting. Let me instead share window then and see what happens. That's very weird. I'm assuming you guys are also seeing a black screen. Okay, it comes up. Okay, that's at least good. So what I was saying is that let's test then the bin. Okay, just a bit of sluggish delay, but it works. So if you want to have different things, one for the first and one for the second, then you need to extend this with another thing too, as I was saying, right? That's the only way. Does this answer? Did I get your question correct, Kurtz, or you meant something different? Okay, just let me know on the chat if you meant something different. I will try to address it. So going back to the implementation, yeah, please go ahead, Daniel.
Professor, I think what Curtis wanted to say is that can you instantiate an object with a type and then instantiate a second object of the same class template, but with a different type? Would that work?
Oh,
but are they the
yes,
same
yes.
objects?
Yeah,
They're
yeah,
not the same
definitely. No, they're not the same object. Exactly, they are different objects. That's exactly the case. So so here, for example, I'm defining similar to what we have done for the function itself. I managed to call the function using an int and then a double and then a character. For the same thing, I can instantiate an object using well, int or character up to me. I'm defining my two pairs to be strings, right? And then I'm comparing them. I can also here write another instantiation saying bear and then int. And then let's say in that case, I will call it bear int. So I can do this. But in that case, bear int or b int will be of type integer, right? So it's a completely different object. So that's the whole idea, is that you have a template class and then objects could have different types, but the same object would have to stick to one type. Okay. So let's conclude with this slide, and then I will utilize the last 5 minutes for an implementation. So again, how does it really work? The idea is a thing, which is your type name, is replaced with the exact template argument when the class is being instantiated, when you create the object. And the class template parameter name is the scope of the template class definition and can be freely used there. So what I mean by this is the idea is you can use thing as far as within the class. So thing is recognized within the class. So thing as a type name is known within that class. Class template member functions also are template functions by default. So once you define a class as a template, all your template or your functions should be templates as well. As you have seen here in our implementation, and even in our header file, I'm using things with the functions, and when I implement them, I'm using them the same way or implementing them using the same way we implemented template functions. So a functions of a class that is a template are template functions by default. Good. Must be defined as template functions outside the class template definition. Only template methods are actually called when, what does it, let me just read that line here. Called in your program are instantiated, but this is an implementation. Only template methods are actually called. Yeah, that's in fact, you don't need to worry about this. Something that happens in the background is that what function is really being called when you instantiate, basically what is mean by called, simply replaced by the actual line, because the idea is I might have inside my template class functions that really don't operate on a thing, so they are not template functions. In that case, the compiler doesn't need really to replace them with a thing and then to do this compile time stuff, right? So in that case, those functions will not be replaced. They will only be left as is. Good. So let's see really how this works in practice, because well, having to see an example might help really with what we have. So let's open online GDB. Let me open a new instance. Okay, so I open a file here. Let me call it bear.h, and then just have my code here. This is something I briefly told you before. It's a good programming practice as well, which is to avoid, for example, if you include header files, multiple header files in a big project, to avoid having a compiler error because of having the same header file included twice. Usually people guard this with this if not defined macro thing, right? So simply what they say is that this is the bare header. If it's not defined, define it. Later on, if you included bear.h multiple times, you will never enter this if not defined because it has been already defined before, and hence the preprocessor will not include your code again. Remember, for example, when we had the point class, the point.h and point3d.h, when we included the point.h in multiple places and we run our code, the compiler complained that there are multiple definitions of the point class. This if not defined thing is a way to guard against it. Oh, you guys are not seeing my screen. Thank you, because I shared window. Yeah, thank you. Because I was just talking to myself. Let me switch. See what nice window. And that's, yeah, thanks, Ching. So hopefully you'll be able to see now. Yeah, this is what I was talking about. Is the bear, if not defined, defined, right? That's out without the compiler complaining about it. But that's again an orthogonal topic. Now, what is important to us is I implemented the template here using this single line. I only have one type of thing. And then I define my class fine, operating on the thing as we have just seen in the example. Good. And then I said we need this line because otherwise the compiler doesn't know where to replace templates. You need the definition. I need this line, which is line 919. There is also a bit of sluggish delay here because I need to include the implementation in the header file as we have already discussed. Now I would add another DB where we will get the actual code of the implementation of the methods here. And then we just see. So what do we have here? I will replace this function, as I told you, with a normal function in order not to worry about function or operator overloading. But the idea is, well, you are operating on your set first and set second. It should take something as an input and set your variable with, and this thing is a thing, right? So it is of type thing. If you get, for the getters, you want to return, but we have already implemented the getters as inline functions here. I don't like this delay. I guess it might make you off, guys, but let me wait for a second. It's really bad. Let me see if I can request control from here. And then where is request control? I don't think I can request control. Okay, let me share from here. So I'll stop sharing. And then I will open online GDB on this end. And let me share from here. C++, C++, maybe white is better. And well, I have changed you, no? Yeah, okay, good. And then we would have to retake the header file. And we will create bear.cbb. Okay, so I'm assuming that you are able to see, right? So in that case, what I was telling you is we have already implemented the getters as inline methods here, right? So I'm just returning first and returning second. So that's good for the getters. Both of the getters are returning a thing because I know that my general type of first and second are thing. For the setters, I'm implementing them in the implementation file, simply taking, well, a pointer to a thing as an input or a reference to a thing, which is copying me, and then assign it to the first and to the second. This is how we set stuff. As we have already discussed, you must really have these as template functions because they operate on a thing. So in that case, you need to write them the same way we have wrote template functions by having this line in like at the beginning of the function or above the function. Good. So maybe the thing I want to change now is let's change this one by call it well, void swap. So I want to add a method. Let's call it void. Or you know what? Maybe let's remove that. We don't need the brain for now because I want to show you a few other stuff. So what if? So let's have an example first of using that, right? So here I come. I include bear.h. Well, just before I forget, inside this implementation, I also need to be aware of the bear. Otherwise, those functions are not associated to the class, right? And then I'm including bear.h. But we have if defined thing, as I was explaining to you, there will be a circular dependency, right? Because the preprocessor will go to the main, it will find bear.h. So it will go to the bear.h, try to include it. At the end, I have .cc. I go to the well, I called it cbb, as soon as cbb. And then I go to the .cbb file, and then I find bear.h. I go back to the bear.h and then find .cc. So there is a circular dependency. This circular dependency doesn't cause us a problem because it will never happen because of if this define, right? So let me explain it to you. The preprocessor will first start from the main. It will find the bear.h. It will go here. This is the first time I access this file, so it's not defined. I define that variable, and then I include everything, and then I exit. Now, when I go to the bear.cbb here, the first line is bear.h. So the preprocessor will go back again to the bear.h. But now bear.h is already defined. So this condition will be false and it will not enter this if statement. So in that case, I guarded against the circular dependency. So hopefully that's clear enough. Okay, so now let's go back and try to use our template class. So I want to include a pair of ints. So in that case, I define something like, well, in our example, what did we start with? An int or a string? I believe we had a string example, but let's start with an int. And then I call this my int pair, for example. Okay. So in that case, I want to initialize stuff. So I will end bear dot set. What did I call it? Set first. Get set. Yeah, set first. Okay, set underscore first. Set under. I need to pass. If I would pass 10. Okay. So I'm passing the first one is 10. The second. Okay. And now implement the two that I have already. So my first. And then I would say end pair dot get. Again, I don't remember the function name. Is it get underscore first? Get underscore first. And then end pair dot get underscore second. Something you observe. My second is something to observe here is I'm using these functions as if they are exactly normal functions. And I know that they will operate an int because I already instantiated my object as an int, right? So everything afterwards from the main perspective is just a normal class or a normal object of a class, right? So let's try to run this and see if we have any problem. Cannot bind non-constant L value. Okay, because I'm passing by reference. And here comes what you guys suggested earlier, because this has to be a variable because I need to pass an address to it. So first of all, what does that mean? So what is the problem here? Remember that we said immediate values don't really have a place in the memory, but here I'm really passing an address. So I need this to be variables. To bypass this, I will try two different things. First, I will define my F and S, like first and second, to be 10 and 20. So I will define them as end variables. And then I will just pass F and S here. Okay. So that a redefinition of thing set first. So why that's the case? Where do CBB? Declared why it sees two different definitions of the same thing? Is that because of the header file problem? Let's see. Let's say if I just take all of this here and just put it here to simplify the problem and see what do we get. So I won. So it's not related to this. Okay. What this is related to? Just passing the address to that variable instead. Nope. Why it sees a redefinition? Okay, line 17. Did I do something wrong? So I'm defining. Okay. So first of all, I will just delete this file. And then here I already fixed this, and then let's run. Okay, again, it's the template issue with the include stuff, which is too stupid. But what we have done is I just followed the simple recommendation I gave to you. You just include everything in the same definition of the class, right? I believe if I removed the bear.h from the bear.cbb should have also worked, but let's focus on what matters and keep this simple implementation, right? Okay, so in that case, my first is 10 and my second is 20, which is as we expect, right? Now, oh, it already 5 minutes past due, but let me show you another example of trying to really not have this as an and thing, because you already had a few questions about this. So let's have the set as just a normal thing and see what do we get, right? and here again from this thing. And let's try this out. I'm passing a normal variable. It should work. Let's see. In that case, it just works as expected, right? And the reason is ints would basically don't need a pass by reference, right? Because you don't need to modify these variables. So I'm just doing a pass by value. Another final thing is, again, I could just come here and define another, let's say, character instant of my class, and I call it character pair. And then I have character, let's say, well, F1 equal A, and then F2 equal P, for instance. And then I just exactly do the same thing, right? Try to print them and see if that really works out of the box. In that case, oh yeah, I'm just calling the original one. This should be character. And this should be character. Here also, this should be character. Character. Just operate on the second object. If I run, I just really get, where is that? Character pair dot get first. Why just gives a new line? It's interesting. So I'm setting, oh, this should be F1 and F2. Okay, that's also my bad because F1 and what did I call the other one? F2. Set them with A and B. In that case, I'm getting my first is A and my second is B, right? So hopefully that makes sense to some of you. Again, it's already 7 minutes past the lecture, but I will stay for 3-4 minutes to take questions. Other than this, thanks everyone.
Professor, earlier.
This example, by the way, will be, yeah. Sorry, so once this example, by the way, will be also posted on Avenue. Yeah, please go ahead, Chris.
Yeah, so earlier, my question, what I didn't quite get the answer, but I think I've figured out now. I just want to double check. So you're using a template variable thing, and then you were defining the class pair. And then my question was supposed to be, when you actually define an object outside of the class of class pair, can that pair be of different types? So can you have an object that is of type int and an object of type pair, since you're passing thing as the variable type? And it looked like the answer was yes.
Let me go back to the example here. I guess this is what you are referring to, something like that.
Yeah.
An object of type int and object of type character.
Yeah. So you just have to write the type before the variable, and that's it. And that's it. Or the object, sorry.
Exactly.
Okay.
Exactly. That's in fact the whole point of having templates, which is allowing objects to be bind to operate on different types out of the same class definition. Because otherwise, without this template thing, I would have to implement bear as 2 different classes, bear for int and bear for character, right? And maybe bear for double, bear for every single type. But now I only have one single class. It's a template class, and then objects will operate on their own corresponding types based on when I create the object, what do I pass here to the template? Yeah.
Okay, thank you.
Great, thanks, Chris. Any other question? Okay, so thanks everyone, and I see you on Friday then. Thank you. Bye-bye.